All right, set's a set, son. That's what we're talking about in example 9. So just to kind of go back over what we've said before, if I have, is 1 a member of this set? And the answer is no. The set of 1 is a member, right? But that's a set with a member of 1, not the same as the number 1. So sets can have other sets as member of their sets, which we talked about quite a bit when we talked about the power set, right? The power set is the set of all possible sets you can make from set A. So let's do this. Let's say A equals 1, 2, 3. Then what's the power set of A? So these are almost all of the sets that we can make from A. But remember, how many potential sets are there in the power set? There's 2 to the n. So what set is missing? The empty set, right? The set of nothing. And now we have 1, 2, 3, 4, 5, 6, 7, 8, right? 2 to the 3, 8. So that is the correct number of sets in the power set. The power set is a set of sets. Okay, now that we understand that we can have sets of sets and we have this thing called a power set, there's another important concept we need to be aware of called a set partition. So a set partition is a set of sets based upon an original set that meets the following criteria. Every element is non-empty. Basically, the empty set is not a part of our partition. So quality number 2 of a set partition is that the union of all elements is A, is our original set A, whatever that is, which means essentially that every member of A is a member of at least one of the partitions. And then 3, and the third quality, if X is a partition of a set and Y is a partition of the same set, then either X equals Y, either they're the same partition, they're the same set of sets, or X intersection Y is the empty set. That is, they have nothing in common. So each partition is unique. All right, let me give you a basic example using our trivial set A at the top. So our partition X is going to be 1, 2, 3. And our partition Y is going to be set 1, a set with 1 and 2, and a set with 3. So let's check our rules there. Is every element of our partition non-empty? That's true. There's no empty set in either of them. Is the union of all elements the same as A? Yes, right? In fact, set X, the only member of set X is the same as set A. But yeah, if we union all of both of these together, we will get set A. If X is a partition and Y is a partition, either X equals Y or X intersection Y equals 0. Well, let's look. We see that X and Y share no elements in common, right? So if we were to take the intersection of them, we would end up with the empty set. So by our definition, each of these is a partition of the set A. Finally, I'd like to talk to you about refinement of a set partition. So refinement of a set partition is taking one or more of the sets within the partition set and breaking it into smaller sets, such that you still have a set partition with more elements in it. And in fact, if you look, you see Y is a refinement of set X. So if we take that 3 element and break it off into its own set, that is a refinement of set X. The only reason that's important is you can look at 2 set partitions and decide which one is more refined than the other based upon the number of elements in the set. Okay, those are all the definitions that you're going to need for set partitions. If you have any questions, ask them in the forum below. Double thumbs up.